So to continue our elevation, so we have to take note that the values of the initial and final grade that the lowest point on the vertical curve will occur when the first derivative of the parabolic function is 0, because the initial and final grades are of opposite sign. So which means that the first derivative of the equation of the parabolic curve, its first derivative will be equal to 0 since the initial and final grade are of opposite sign. So you have to take note that when the initial and final grade are not in opposite sign, the highest or the lowest point on the curve will not be where the first derivative is 0, because the slope along the curve will never be 0 since they have different sign for the initial and final, since they have the same sign for the initial and final grade. So for example, a sag curve with an initial grade of negative 2.0% and a final grade of negative 2.0% will have its lowest elevation at PVT. And the first derivative of the equation will not be equal to 0 at any point along the curve. However, in our example, for this example, you have to take note that the the first derivative will be equal to 0 at some point since the initial and final grade are of opposite sign. So therefore, our low point will occur when? So the low point on the curve will occur when the first derivative is equal to 0. So which means that dy over dx, which is equal to 2ax plus b. This is the first derivative of our parabolic equation of the vertical curve, and dy over dx, which has the slope, is equal to 0, which is equal to 2ax plus b. And we have to take note that our b, which is equivalent to g sub 1, actually this is our initial grade, which is equal to negative 3.5. And for our a, which has one of the coefficient, a is equal to g sub 2 minus g sub 1 all over 2l. So therefore, if we try to substitute, we have here 0.5 minus negative 3.5 all over 2 times 6, and this will give us 0.3333. So we have now the value for our coefficients a and b. So therefore, if we try to substitute the value for a and b in our equation, which is in this equation, so which is dy all over dx is equal to 2ax plus b. So this is 0 is equal to 2 times 0.333 times our unknown x plus b, which is negative 3.5. So therefore, if we try to simplify, our value for x is 5.25 stations. So actually, this is the distance from PVC towards our lowest point. So the lowest point is at distance 5.25 stations. So if we're going to have this curve, so therefore this is our PVC, this will be our PVT, and somehow this will be our this will be the position for our lowest point, which is 5.25 stations. So therefore, from PVC towards PVT, the stations here, actually this is the distance from PVC towards this lowest point, which is 5.25 stations. So actually the station, this elevation, this point is located at 175 plus 25. This is the station, because this is 170 plus 00, that is the station at PVC. So now we are going to compute what will be the elevation of this lowest point. So we're going to make use of the equation y is equal to ax squared plus bx plus c. So our y, this is the elevation of the lowest point. So the elevation at lowest point, having a distance of 5.25 station from PVC. So therefore, this will be equivalent to 0.333 x squared our x is 5.25 squared plus b, which is equivalent to negative 3.5 times 5.25 plus c, which has the elevation at PVC. This is 1,000. So therefore, if we try to simplify our y, which is the elevation at the lowest point, is 990.81 feet. The second problem is an equal tangent vertical curve is to be constructed between grades of negative 2.0%, which is the initial grade, and positive 1.0%, which is the final grade. The PVI is at station 110 plus 00 and at elevation 420 feet. Due to a street crossing the roadway, so there is a street crossing the roadway, the elevation of the roadway is at station 112 plus 00 and must be at 424.5 feet. So you're going to design the curve. So for this problem, we have to take note that for this one, we are going to identify our the sign of the curve. So we're going to identify the length of the curve, for instance. So the design problem here is to determine the length of the curve actually. So we're going to identify the length of the curve, which is required to ensure that the station 112 plus 00 is at elevation 424.5 feet. So to start with our solution, we make use of our equation, parabolic equation, which is y is equal to ax squared plus bx plus c. So we have to identify our b and our a. So our b here is g sub 1, which is our initial grade, negative 2.0, and our a here is g sub 2 minus g sub 1 all over 2l. So therefore, if we're going to have this values, this will be g sub 2 is 1.0 minus negative 2.0 all over 2 times L. So if we try to simplify, this will give us 1.5 all over L. So therefore, we have now identified our values for our A and B. So we have to take note that our C from our parabolic equation of the vertical curve is the elevation of our PVC. So if we try to identify the elevation at PVC, that will be equivalent actually to the elevation of PVI plus G sub 1 times 0.5 of L. So meaning to say, if this will be our curve, so we have here our PVC, this is our PVI. So we have to take note that our PVI is lower in lower in elevation compared to PVC. So therefore, the elevation at PVC will be equivalent to elevation at PVI plus the initial grade, which is G sub 1, multiplied to the length or the distance from PVC towards PVI. You have to take note that this one towards PVT is our L. So this is L over 2 or simply 0.5 of L. So this is times 0.5 of L. So if we try to substitute the values here, our elevation at PVI is equal to 420 plus our grade, initial grade is 2.0 times 0.5 L. So therefore, if we try to simplify this one, you have 420 plus L. So we have now our C, which is the elevation at PVC. So we have to take note that the station at PVI, this station is at 110 plus 00, and this point of interest, which is the station is at 112 plus 0. So therefore, if we're going to have our x here, the distance of this point towards PVC, so actually this will be our this is our x. So this x here is actually equal to this distance from PVC towards PVI is 0.5 of L. That distance from PVI towards this point is 2 station, because this is station 110, this one is station 112. So that is this distance towards that distance is 2 stations. So therefore, our x here actually, our x here is will be equivalent to the point of interest at this point is 0.5 L plus 2. So therefore, if we're going to make use we're going to solve for L. We're going to identify the value for L. So let's identify. Okay, so that's the one actually. The value for L that we're going to have here. So if this will be, so if we're going to have our L here, so you may make use of our equation, this equation, you make use of that. And if we try to substitute the values, our y, which is the elevation at this point, the point of interest is 424.5, which is equal to A, which is 0.5 of L, 0.5 all over L times our x is 0.5 plus 2 raised to the second plus, so this is plus, this is b times x. B is negative 2, our x is 0.5 plus 2, then plus c. Our c is this one, so this is our c actually, so this is plus equivalent to 420 plus L. So therefore, simplify this one so that we can identify the value for L. So if we're going to have, if we try to simplify this one, this will be quadratic. So the values, the simplified form will be in quadratic equation. Actually, the quadratic equation here is equal to 0, is equal to negative 0.375 L squared plus 5.5 L minus 6. So that will be the equation. So therefore, this is quadratic. So meaning to say, we have to resolve this, and there will be two values. So one value is the values is 1.187. So 1.187, the value for L is not feasible, because if you're going to observe from our distance alone from PVI towards this point of interest is already 2 meters. So this is not feasible. So L is not 1.187. So therefore, the L which should be greater than 1.187, and L is, the other value is 13.466. So therefore, we have here two values for L. From the equation, 0 is equal to negative 0.375 L squared plus 5.5 L minus 6. Quadratic equation, one value is 1.187 station. The other value is 13.466 station. So this one is not feasible, since from our curve, if this is our PVI, this is the point of interest having a distance of 2 station, because this is 110 plus 00, this station is 112 plus 00. So that distance alone is already 2 stations. So this is our PVC. So therefore, L, which is 1.187, is not feasible. So therefore, we have to choose that our L is 13.466. L is 13.466 station, or this is equivalent to 1,346.6 feet long.